For decades, our understanding of the early universe has been a grand narrative, meticulously constructed from the echoes of the Big Bang. We envisioned a cosmos where, in its infancy, only the smallest, simplest galaxies could exist, slowly growing into the majestic spirals and ellipticals we see today. Then came the James Webb Space Telescope, humanity's most powerful eye on the distant past. Its breathtaking images, peering further back in time than ever before, are rewriting this cosmic history. JWST is revealing galaxies in the very early universe that are unexpectedly bright, massive, and chemically complex. These aren't the tiny, nascent star clusters we anticipated. They are cosmic leviathans, challenging our most cherished models of galaxy formation and early universe evolution. They are monsters in the early universe, defying the timeline our standard cosmology suggests. What unseen forces could be driving such rapid, efficient cosmic creation? How could such grand structures form so quickly after the Big Bang? At the 11-dimensional model of the universe, we propose a revolutionary answer. These surprising galaxies are not anomalies. They are direct evidence of a deeper dimensional blueprint at play. Our model offers a unique, fundamental explanation for how the intricate interplay of 11 dimensions actively orchestrates cosmic formation, revealing the true architects of our universe. The James Webb Space Telescope is a marvel of engineering, designed precisely to capture the faint, stretched-out light from the first stars and galaxies. By observing in infrared, JWST allows us to see back in time, often more than 13 billion years, to within a few 100 million years of the Big Bang itself. What it's finding is both exhilarating and perplexing. So, astronomers, well, they expected to see small, somewhat disorganized baby galaxies just slowly beginning the process of gathering gas and forming their first stars. But instead, the James Webb Space Telescope is routinely discovering galaxies that are, quite frankly, unexpectedly massive and bright. Some of these early galaxies are far larger and contain far more stars than our standard cosmological models would predict for their age. For instance, a few of them have already formed billions of solar masses in stars when, according to lambda CDM, the standard model of cosmology, there simply hasn't been enough time for gravity to pull together that much material and for stars to form so rapidly. And here's another surprise. These galaxies are chemically complex. The light coming from them reveals the presence of so-called heavy elements like oxygen. Now, heavy elements are forged in the hearts of massive stars and only get spread into the cosmos when those stars explode as supernovae. So finding them this early in the universe implies that not only were a lot of massive stars forming, but they were also living and dying incredibly quickly, enriching their galactic environments at an astonishing rate. These galaxies also appear to be responsible for early reionization. The universe began as a hot, dense plasma, then cooled into a neutral fog of hydrogen. It was then reionized by the first light-emitting objects. Well, JWST is finding evidence that this reionization process happened earlier and more efficiently than we previously thought, potentially driven by these surprisingly bright early galaxies. These observations pose a significant challenge to the standard lambda CDM model, which, while highly successful, struggles to explain how such massive and chemically mature galaxies could have formed so quickly in the tender infancy of the cosmos. It's a cosmic miracle, or, an unexpected efficiency that demands a deeper explanation than simple gravitational aggregation alone. Our 11-dimensional model offers a revolutionary perspective on this cosmic enigma, providing the missing pieces to account for JWST's surprising discoveries. It begins with the fundamental architecture of reality. The universe is actively orchestrated by the expansive 10th dimension and the contractive 11th dimension. Their ceaseless interaction generates the universal wave, the very fabric of existence itself. In this model, the universal wave is not just a passive medium, it is an active cosmic blueprint, a dynamic field that fundamentally orchestrates the formation and organization of all matter. Every particle, every star, every galaxy forms as a specific dimensional resonance, a stable knot or condensation, within this pervasive wave. The conditions for matter to condense and aggregate aren't solely determined by local gravitational instabilities in three-dimensional space. They are fundamentally influenced by the underlying topology and dynamics of this higher dimensional universal wave. The universal wave preconditions regions of space-time, making them far more efficient for matter aggregation. To truly grasp how the 11-dimensional model explains JWST's observations, let's revisit our cosmic sluicebox analogy, but let's reimagine it for those intense early moments right after the Big Bang. So, recall. The water flowing through the sluicebox represents the 11th dimension, with its pervasive quantum probabilistic nature. The riffles and the overall shape of the sluicebox represent the 10th dimension and other higher dimensional interactions, providing that deterministic structure that influences the flow. The eddies created behind the riffles are the emergent 1st through 9th dimensions, regions where conditions favor condensation. And finally, the gold or heavy elements are matter, gas, dark matter, and of course forming stars and galaxies. In the very early universe immediately following the Big Bang, which itself, in our model, could be viewed as a monumental dimensional unfolding or perhaps a synchronized eruption of white holes, the dynamics of the universal wave were in an incredibly potent and efficient state for matter condensation and galaxy formation. This implies that, the interplay of the 10th and 11th dimensions was creating conditions where the eddies in the cosmic flow, the regions predisposed to accumulate matter, were far more powerful, widespread, and efficient. These weren't just random pockets of higher density, they were actively orchestrated zones of dimensional resonance, drawing in surrounding gas and early dark matter with honestly unprecedented speed. Accelerated aggregation, this fundamental dimensional orchestration allowed matter to aggregate much faster than simple gravitational collapse alone would predict in a purely four-dimensional universe. The universal wave was acting as a highly efficient cosmic vacuum cleaner, rapidly collecting and compacting the primordial soup into dense galactic foundations. And, this explains the observed accelerated galaxy growth that puzzles standard models. With the 11-dimensional model, JWST's surprises transform into, compelling confirmations of a deeper reality. So, unexpectedly massive and bright galaxies, the model actually accounts for the rapid accretion of mass thanks to this exceptionally optimized dimensional resonance, as well as the strong eddies in the universal wave that really defined the early universe. This in turn allowed galaxies to gather billions of solar masses in stars much faster than gravity alone would have predicted, which made them, unexpectedly bright. Early chemical complexity emerged because the rapid and efficient gathering of matter into these dense early galactic eddies naturally led to these incredibly fast cycles of star formation. More massive stars formed quickly, lived short lives, and then exploded as supernovae, enriching their galactic environments with heavy elements like oxygen at a truly astonishing rate, much earlier than conventional models could ever account for. Efficient early reionization, now these early, massive and efficiently star-forming galaxies being fundamentally favored by their dimensional structure, would have been powerful sources of ionizing radiation from their very inception. This allowed them to, clear the cosmic fog, reionizing the neutral hydrogen across vast swathes of the universe earlier and more efficiently than we previously thought, which aligns, quite remarkably, with JWST's observations. The James Webb Space Telescope, peering into the universe's infancy, has presented us with a profound enigma galaxies that simply shouldn't be as mature as they are. This challenge to our standard cosmological models is not a flaw in the universe. It's really an invitation to expand our understanding. The 11-dimensional model provides the missing pieces. It reveals a cosmos where creation is not merely a random aggregation of matter, but a beautifully orchestrated process guided by a deeper dimensional blueprint. The unexpected efficiency of early galaxy formation, their rapid chemical enrichment, and their role in cosmic reionization are all powerful testaments to the active influence of the 10th and 11th dimensions. By embracing this model, we gain a new cosmic map, one where the universe's most surprising discoveries find a coherent and elegant explanation. It's a universe that is far more dynamic, more interconnected, and more fundamentally designed than we ever imagined. The cosmic architects are not hidden, they are the very dimensions shaping reality. Let the mysteries of the universe spark your imagination. Subscribe and join us as we journey deeper into the cosmos, where every answer leads to new wonders waiting to be discovered.